our like terms are, and we had said back in August that like terms have the same variable with the same exponent. Okay, so this is something we've said before. This is something that we used when we were solving equations. And we've used it several times since, but we haven't really had to worry about the exponent part before. Now we do. So now that we have to worry about the exponents, can someone point out where our like terms are in this problem? No ideas? Regine? Yep. 9x and minus 4x, those are like terms. They both have x to the first power. Are there any others, Robin? 3x squared and 2x squared, they both have x to the second power. Same variable, x, same exponent, 2 or 1. Those are the things we're going to be combining. The question then is how? What are we actually combining? If you read through this problem, I'm supposed to be doing 3x squared plus 2x squared. So then the question is, well, I know 3 plus 2 makes 5. That part's usually a natural assumption. 3 plus 2 is going to make 5, and that's a correct thing to think. The idea here is, well, what am I going to do with the exponents? I have x squared and I have x squared. Well, let's run through the process of things that we've done. If I were going to add these exponents, we did problems where we added exponents. What were we doing when we added exponents? Someone said it. We were multiplying. Are we multiplying here? No, so we should not add the exponents. Should we multiply the exponents? What happened when we were multiplying exponents? What kind of a problem was that? Power to a power. Do I have an exponent that I'm bringing in onto my exponent? So we're not going to multiply these exponents. We already said we can't add them because it's not a multiplication problem. We can't subtract them. It's not a division problem. The only option left is to divide them, right? Definitely not what we're going to do. There's something else. We can't add them. We can't subtract them. We can't multiply them. We can't divide them. Spencer? Leave it the same. Winner. You literally do nothing to them. And here's why. The idea is that x squared, this is some number times itself. We don't know what the number is, right? That's the point of having a variable. So x squared, whatever that happens to be, it has some value. X squared is a thing, and it is different from just x. I have 3 of these x squareds here, and I'm going to add 2 more of these x squareds here, giving me 5 of these x squared, whatever it is. I haven't changed the value of x squared. I haven't changed what it is. I haven't changed what I do to it. I've changed how many of them there are. It's the same thing as what we did here. And this part should make more sense. This is what we did with equations. If I have 9x minus 4x, isn't that supposed to make 5x? We did that with equations. We don't change the exponent. X doesn't all of a sudden go away. It's still there. So the big thing we need to pay attention to here is that the exponents do not change when you're adding and subtracting. This right here is a final answer. I cannot combine these things any further. This has x squared, this has x to the first. They are not like terms. They cannot be combined, and that is a final answer.